Today our student outcomes will be to interpret the meaning of the point of intersection of two graphs and use tools to find the coordinates of that point of intersection. So we're going to have two graphs. We've got to find that point of intersection using different methods. Now, the very first question we have, it says Duke and Shirley's story. Just like the previous problems we have, what we are going to see here is that I do have the notes filled out already on this video, so you're going to fill out as I talk you through them. There'll probably be things as I add as I go along. So this very first question says, Duke starts at the base of a ramp and walks up at a constant rate. His elevation increases by 3 feet every second. You notice I underlined it because it's going to be important. Just as Duke starts walking up the ramp, Shirley starts at the top of the same 25-foot high ramp and begins walking down the ramp at a constant rate. Her elevation decreases 2 feet every second. First question says, draw two graphs on the same set of elevation versus time axes to represent Duke and Shirley's motions. I was hoping the color would come out better, but I think you can tell the difference. I drew Shirley's in blue and Duke's in black. Before I could go and just draw their graphs, though, I had to come up with some labels for the axes. So it does say in the problem it's an elevation versus time axes. Time is called our independent variable. It's going to go on the x-axis, and elevation is going on the y-axis. Now I know my time is in seconds because it says the elevation is changing feet per second. Feet per second. So time is in seconds, elevation is in feet. I chose to go up by ones on the seconds. I did start at time 0. It means the very beginning. Elevation, I knew I needed to get up to 25 feet because that's the height of the ramp. When I counted these boxes, I had 25 boxes, so that worked out well. I did not label every single one of those lines. I went up by I labeled every 5th one, so you can see that there. If you need to, pause the video and draw in your axes. Moving on, I'll start with the information for Duke. Duke's elevation increases 3 feet every second, and he started at the base of the ramp. So since he started at the base of the ramp at time 0, he's at 0. His elevation increased 3 feet for every 1 second. So that's just your slope. So we're going up 3 and then right 1. Up 3 feet in 1 second. Up 3 and keep following the pattern all the way to the top. And you can draw a line to connect your dots. Shirley, on the other hand, she started out at 25 feet high because she started at the top of the ramp. And she walked down. Her elevation decreased 2 feet every second. So at time 0, she was at 25. And since it only decreased 2 every second, down 2, right 1. Down 2 feet in 1 second. Down 2 feet in 1 second. And so Shirley's goes all the way down. When you guys are set, you can look at the back of your page. I'm not going to go there yet because I want to have the graph in front of you as I'm explaining it. But I'm going to go through the first few questions now, so please fill those in as you go along. On the back, the first one says, what are the coordinates of the point of intersection of the two graphs? The point of intersection are where the two graphs meet, which is right here. We can see that that point is 5:15. So for number 1, the point is 5:15. Again, 5 for the 5 seconds and 15 for the height. Number 2 says, at what time do Duke and Shirley pass each other? Well, they are passing each other right at this point right here. That's where they meet up. And that time is 5 seconds. So for question 2, please put pass at 5 seconds. At this point, I will go on to the next page. So you guys, okay, you can see my answer is 5:15, pass at 5 seconds. Number 3 says, write the general equation of a line in slope-intercept form. The equation of a line from last year, I hope you remember, is y equals mx plus b. Complete some sentences below. Average rate of change is another way of describing, and I've actually used this word already, slope. When he was decreasing when she was decreasing at a rate at 2 feet per second, or Duke was increasing at a rate of 3 feet per second. So their average rate of change was their slope when we graphed it. Number 5, write an equation of a line that represents Duke's motion. So this is our general equation, y equals mx plus b. M is your slope, and b was your y-intercept. So in this case, Duke's slope was 3 because he increased 3 feet every second. I drew a little sketch over here. You don't need this sketch. This was just so I can refer back. And Shirley's decreased at 2 feet every second, so that's why hers is a negative for a decreasing, and went down 2 feet for every 1 second. So that's where I got the 3x and the 2x. The y-intercept, or the starting point for Duke, was at a height of 0, while the starting point for Shirley was a height of 25. So we could write it as 3xy equals 3x plus 0. But I'll write it as y equals 3x, so I don't need that plus 0 there. Shirley, on the other hand, I could write it as y equals negative 2x plus 25, or I could write it as y equals 25 minus 2x. It does not matter which way you write it. Question 6. Show that the coordinates of the point of intersection satisfy both equations. It means show that this point, 515, works in both of the equations you made. So, for y equals 3x, I plug in the point 515. 3 times 5 is 15, so 15 equals 15. And the same with the other equation. I plug in the 5 and the 15 in their respective spots, and I end up getting 15 equals 15. So I did show that the point of intersection satisfied both equations. It's like a little check to make sure you did your equations correctly and that you found your intersection correctly. Number 7, when does Shirley get to the bottom of the ramp? How do you know? Shirley gets to the bottom of the ramp right here. If I go back to even to my other graph, that doesn't land on a nice even second mark. But she will get to the bottom of the ramp when her elevation is equal to 0. So what I did is I set her elevation, which was her y value, equal to 0. And I solved for x. I end up getting 12.5 seconds. How do you know? I have a nice little sentence here, and I will be expecting you guys to write sentences in math this year. Shirley gets to the bottom of the ramp when her elevation, which is her y value, is 0. So we set the equation equal to 0 and solve. A couple of important vocab words we have here. The intersection point of the graph of the two equations is an ordered pair. 5, 15 in those parentheses, that's an ordered pair. That is a solution to both equations, means it worked in both equations like we saw in number 6. In the context of distance or elevation story, this point represents the fact that both distances are equal at a given time, meaning that they were both at a height of 15. Graphing stories with quantities that change at a constant rate can be represented by piecewise linear equations. We will investigate these types in the future. Okay, moving on. Example 2, designer coffee mugs profit story. The graph below shows the revenue or income of a company makes from designer coffee mugs and the total cost, including overhead, maintenance of machines, etc., that the company spends to make that coffee mug. Just so you guys are aware, cost is going to be the one that starts at 4,000, and revenue will be the one that starts at 0, in case you can't tell on yours, like I can't tell on mine. Letter A, how are revenue and cost related to a profit the company makes? Profit is the money that you actually make. Revenue is the money you bring in. Cost is the money it costs you to make the item. So to get the profit, it's equal to the revenue minus the cost. What is the meaning of the point 0, 4,000 in the total cost line? So 0, 4,000 is that point right there. What does that mean? Well, that's your fixed costs. All right, it's what it costs the company before any mugs are even made. So before I even make one mug. So maybe the cost of buying the machines, of running the factory, that type of stuff. That's a fixed cost. Letter C, what are the coordinates of the intersection point? Well, they're right here. You could probably see them better before I drew my lines in. But that's at an X value of 500 and a Y value of 6,000. So that is where the company will break even. Before this point, the company lost money, and the reason I can tell, cost was higher on the graph than the revenue. After this point, the money I'm bringing in is more than the cost it is to make the item. So at this point, I'm making a profit, and that's what that says there. Again, notice I'm using words in my math class. Letter D. Create linear equations for revenue and cost in terms of units produced and sold. The way I can come up with an equation, it looks like I did the revenue first, which is my blue equation. I came up with 2 points on that line. I chose the point 0, 0, and I chose the point, I believe I chose the intersection point. The intersection point is 500, 6,000. If I go down and look at my work, and that is exactly what I chose. To find the equation of a line when you're given 2 points, you have to find the slope. The slope formula is y2 minus y1 over x2 minus x1, which when I plug in my points, 6,000 minus 0 divided by 500 minus 0. You get 6,000 over 500, which is a 12. Remember we discussed this in the previous problem. The y-intercept is where it hits the y-axis. In our case, it starts at a y value of 0. So I didn't even put plus 0, but it could be y equals 12x plus 0. For the cost function, again, I came up with 2 points. I used the point 0, 4,000. And I also used the intersection point again, 500, 6,000. I found my slope using the slope formula. 6,000 minus 4,000 divided by 500 minus 0. Subtract and divide out the 2,000 divided by 500, you get a 4. So my equation is y equals 4x plus 4,000. Now why is it 4,000? Hopefully you're saying it's because the y-intercept is 4,000. I started at a y value of 4,000 on that cost graph. Letter E, you guys are going to try right after this video. Verify the coordinates of the intersection point. Just plug your intersection point, that 500, 6,000, into both equations. Make sure it works. So you guys are going to do that right after I'm done with this video. And finally, letter F, profit for selling 1,000 units is equal to the revenue generated by selling 1,000 units minus the cost of making 1,000 units. So we have to find the revenue of making 1,000. The cost of making 1,000, and since it says it's the difference, this is minus, but it's the difference, you subtract them because profit is the difference between revenue and cost. So you plug in 1,000 into your revenue equation, plug in 1,000 into your cost equation. It means you made $12,000 when you sold 1,000 units, and it means that it cost you $8,000 to make those 1,000 units. Subtract. Profit that you end up making on those 1,000 units is $4,000. At this point, you guys can do letter E. I will check that you completed the video tomorrow in class as well as tried letter E, and we will work on what's called lesson 1 homework in class tomorrow.